which image is for which RGB channel. Recently, I was looking into RGB color model in the Wikipedia, and I came across this image, which I found it really interesting. As you can see, this image has been taken in 1911, and the photographer has used 3 exposure filters. But at the time when I looked into the right-hand side of the images, I thought like, okay, now which one of them do they belong to what channel? So red, green, blue. And I decided to basically do the practice and do this operation in Python and using Numpy. So that's what we're going to see today. If you think that this is something that you'd like to do, this is very simple, quick operation using Numpy, and I'm pretty sure you will find some useful material for this. So please continue watching this, because I'm going to go through some material, basic fundamentals, and then we're going to do this in Jupyter Notebook. So with that, this image basically, as you go to the RGB color model, you would be seeing this image at the bottom of it. Like I said, the subtitle of this image also gives the answer to this, which is blue, green, and red filters. So if you click on this one, you see this image, and we're going to use a hyperlink to do the operations. Going back to our slides, as the title of the video indicates, we're going to use Numpy for this set of operations. And if you came across scikit-learn MNIST dataset, you know this is a really large handwritten digits dataset, basically, which we use it for training various image processing operations. So in here I'm showing number 1. This is basically a handwritten one from the kids, and this, when we print it out, it's or bring it within the Numpy, you will see that this is a 28 by 28 vector. In other words, this is like 28 by 28 pixel image. And when we basically print out the numbers within these arrays, you see that we have a bunch of zeros and some digits like 1 and 0.7, 0.5, all those numbers that we are seeing here. So again, relating these two, you could see that pixel darkness is indicated by the values that we are seeing between 0 and 1. 0 is white, and 1, of course, is 100% darkness. Often the range that we see for these kind of images are between 0 and 255. Of course, this could be normalized to 0 and 1, but for the sake of visualization, it doesn't matter. So we could take this approach to the colors. As you know, each color could be created by mixing the 3 main colors that we have, red, green, blue, as RGB. And we use the same approach that we had. So we're gonna create basically a 3D vector, which includes the intensity for each of them in each of those basically directions, I would say. If you want to read more about this, then you could just take a look into the Wikipedia RGB color model, where actually I started this video. We're going to bring in this image that we saw before, and you see that this image has the size of 847 by 1280 by 3, and 847 is the width of it, 1280 is the length, and 3 is the number of the colors. Of course, if you go to look into this image, we might be having different numbers because they have on Wikipedia different resolutions. So when we are picking this, we might be again not be able to 100% see these numbers, but you get the idea. Also, we're going to look into another example, which is OpenCV. So you're seeing in here, this was the original image, and in this presentation you don't see the OpenCV here because I have chosen the darker background. But if we go with a lighter background, you see that OpenCV is obvious, and the rest of these numbers that you're seeing are transparent, so that's why it becomes black, and we are not able to distinguish the OpenCV from the background. So the other channels that we had there are RGB. So if we go, we're going to basically regenerate the red, as you can see here, green and blue channels, and also we're going to be able to do the operations of doing the grayscales, and we regenerate the images that you're seeing, these representations. And the image that we're going to choose is an NPG, and it's going to have the fourth channel. And the fourth channel indicates the alpha or transparency, and the numbers which we are going to see for them are going to be between 0 and 255, and 0 is 100% transparent, and 255 is not, which is opaque. So with that, let's go to the Jupyter Notebook and do this operation there. We're in Jupyter Notebook, and we're going to import some of the libraries that we need. Of course, we're going to need Numpy, as the title of this video suggests, but Numpy is a great library that we could use to operate with images. However, we need to use some other libraries such as PIL, Python Imaging Library, to basically be able to access and read these files, image files. So let's import Numpy as NP, and we're going to also import matplotlib pyplot as PLT, and also we're gonna grab the link or first import requests and import PIL, or from PIL we're gonna import image, and the URL that we're gonna grab is here on the RGB model coming down here. This is the image that we had, and more details, and it has the image on the right size that we want to use. We grab this image, bring it here, and this is our URL. So we have the image open and requests. So we use the get for the URL, and we have the streaming as true, and we grab the raw portion of that, and I guess that should do this. Of course, we need to assign this to a variable. I call it IM, and this is the image that we saw initially. And if you look into the type of this, you could see that it's not a NumPy array. So now it's a PIL type, and we need to convert this basically. So I would say create an array from this, which you could say as array or array of the IM. And now we could actually plot this using the matplotlib. So plt.imshow, and pass in the imr, and you see the same plot as we saw there. Of course, if I wanted to modify the size of this, I could add the fig ax as the plt subplots, fig size equals, I use the double. Alright, so I'm passing the AX, and this is the size that we'd like. So now we have this. If we wanted to show one of those channels, say in channel green, I could just pass in all of those, and RGB, red 0, green 1, so I'm going to just pass this, and we're going to see this as green. And if we wanted to see this in the other black and white, to see which one of them becomes like, is the yeah, basically which one of them is our red or which one is the green. So I could just pass here the CMap as gray, and here we go. So you could see that this one is corresponding to this one. So this is the green. Of course, we didn't know it is this way or this way. So is this the red one or this one is the red? So what I'm gonna do is just copy this and bring down and pass in 0. So you see that this is the red channel in the gray color map, and also this is the red one. So the subtitle that we saw on the image originally is correct, which is blue, green, and red. So the other color, another thing which I wanted to do is, like, if we go and we basically changed all the other numbers that we had in other dimension, and the dimension of 3, say, like, modify them, the 1 to all the zeros, what would we get? And to do that, I'm just going to create a copy of this and pass in here and say the red image a copy of this, and red image, all of them except the first one. We make it 0, so we're gonna copy this, and this one too. So now we're gonna copy this, what we had here, and bring down, and this time instead of just selecting the portion which I want, I'm gonna pass in the red image. And here it is, the image in red. And again, you can see this is the red channel and also the red channel that we are seeing in here. Okay, so the second example which I wanted to show is for the case which we have the PGM file and we have the fourth channel, and that's where the alpha variable is given. This is for opaque or transparency. And so if we come to our Wikipedia and search for OpenCV, we find the image that we'd like to get, and we come here and right click, copy image address, and we're going to copy and come here and paste the link as URL as it's given. And you can go use the previous codes that we had up here and grab those. Alright, same way as before, we can put the image URL in here, and we're just gonna here I added the headers, and it's kind of mostly replicate a user agent who's going to browse it. This is something sometimes for the security purpose the websites have it to stop the bots and scrollers. So so we have this as shown here, and the image is shown as you could see here. So next, same way that we did up here, we can grab one of those channels. Say we want and grab the channel for green, coming down, come to over here, and this time we also need to define the image array, and we're going to define this as np.array, and we called it im2. So this is an array, and now you could see that this is the green channel. Going up here, this is the green channel shown in this color map, and we could just put the color map as gray. My apologies, I guess. And it looks like this. So this is similar to what we saw before, which we are creating this aspect. So if we want to look at the fourth channel and plot that one, we can come back here and copy the whole thing, paste it here, and instead of 2, we're looking at channel 4, which is 3. And we don't need to put any color map. So we can get, as you see here, and if you use the color map as gray, you see it in black and white. So what are these numbers that we are seeing here? So basically, if we look into IMR and third channel, I'm sorry, the fourth channel, you see the numbers that we are seeing, and this is of course between 0 and 255. As you can see here, the maximum values are 255. So the 255 is for where we want to be opaque, and 0 is when we want to be transparent. Alright, that's what I had for Numpy for images. I hope you found it useful, and I'll see you in the next video.